Good morning, all. My name is Gitanjali Mishra, research scholar from CIT University, Gunapur. It's my great privilege to present my conference paper, which ID is 71, and the title is Fuji by GRU-based hybrid extractive and abstractive text summarization for long multi-document. This is my abstract. So when we are using different sources of documents as input for text summarization, it is called as multi-document, and it is the biggest challenge in the automatic text summarization field. So this motivates us to work long documents, and which is multiple documents, by calculating its sentence score using fuzzy inference system. From the extracted sentences, the similarity or the redundancy will be eliminated by using by GRU, and then an abstractive summary will be generated, which is identified based on the sentence. The proposed system will validate and test using the standard dataset, that is DUC, BBC News, and CNN Daily Mail. The proposed Fuji by GRU is compared with other existing models and gives the empirical results, which indicates that it outperforms all other models in terms of ROS, N, and L scores. So these are the literature survey which we have done. So in article 14, the Fuji logic and PSO, that methodology is used, and by using that methodology, we got these advantages. The result shows that the proposed method has better performance using the swarm intelligence on the benchmark dataset. And here we where ROS is used for evaluation. In 15 article, the methodology is used as fuzzy inference system. So by using this fuzzy inference system, the advantage we have seen that this model gives the linguistic variable and human perceptions are taken into consideration. But here it will take much time to get the summary, and for evaluation, same the ROS is used as a matrices. In 16 article, both the Fuji inference system and ANN, that is the combination of both, will be used here. So by using this, so you have seen that it gives the relationship between the input and input sentences relationship, and it will give the implicit knowledge of the neural networks when it can be learned. Here, least square estimate method is used to minimize the square error and the actual output of the target output. But here we have seen it will work only for DOC 2002 dataset, which is used, and subsequent t-test is used, and which gives the output which will take much time. And it should not be noted that sentences was not evaluated as per the criteria. And larger data set, it will not for larger data set, it is not tested or the validated. That is the disadvantages by using this Fuji inference system and ANN. So in 17 articles, same the Fuji inference system with the help of ANN that is used, but it handles the uncertainties in the input by calculating the sentence score using different types of membership functions, and it handles the words better than other statistical techniques. But the disadvantage is that the 50% of other surveys have not been used this data set, and the standard studies has not been done by using the benchmark data set. In article 18, the ANN Fuji inference network is used. So it uses we got the advantage that it gives the swarm intelligence method, which is used to optimize the power of PSO, and it outperforms other methods on DU dataset. It generates the data-driven model set of the Fuji rules. The problem is here the absence of the large corpus For better training, no testing of this model is done for multiple document summarization. So these are the some of the literature survey which is done. So this is our proposed architecture. So in these proposed architectures, we are inputting the multiple documents from 1 to n, and that multiple documents are inputted, and first the pre-processing is being done with that n number of documents. So in the pre-processing, we are doing these activities like document segmentation, paragraph segmentation, word normalization, tokenization, and staining. That is coming under your pre-processing. So after doing pre-processing, so next phase is that we need to extract the features from the pre-processed data. So in feature extraction, so how can we extract the feature that based on these 8 characteristics, that is title, summary, sentence, length, numerical data, TF-IDF, position score, proper noun score, the metric score, cosine similarity. So based on these criteria, the features are extracted from the pre-processing data. So after feature extraction, that is given to the Fuji rule based model. So in this Fuji rule based, the sentence will be scored or ranked. So after ranking the sentences using Fuji rule based, that is given to the by GRU. So this by GRU will select the sentences which is scored by using Fuji rule. So finally, the sentences which are whose score is highest, that will be selected, and after that we are combining or concatenating that sentences which is selected by using the rank sorting. Then finally we are getting the output. This is our proposed architecture. So in the pre-processing, the fundamental step that actually it is removing all the noisy information from the input data. So basically this takes summarization. We segment the document into first we are segmenting the documents into number of paragraphs, then paragraph is further segmented into the sentences, and sentences are segmented into the number of words. So we store these words corresponding to each sentences as a vector format, where for each vector we perform the other various pre-processing functionalities named as word normalization, tokenization, case folding, POS tagging, and stemming. In feature extraction, once the ambiguities or the repetitions or complexities that will be removed from the input document, then the document is organized into sentence feature matrix. So in this step, feature extraction contains 2 components. First step is that we will extract the words, feature words. Then after we are extracting the features of individual sentences. First we will extract the words, then we are extracting the features for the sentence based on whose score will imply the rank to the corresponding sentences for the subsequent summary generation. In feature extraction, and then that is combination is given as by how do we select the features based on these criteria. First criteria is the length of the sentence, word frequency and title similarity, position of the sentence, and sentence to sentence cohesion and heading similarity. So using these above steps, we get the better coherence between the summary, the length of the summary that will be reduced to 1/3 of each heading. So here the sentences will be selected as per the heading. So for every single document problem that will be treated as here the multiple document summarization problem, each heading will be considered as a separate text. Thus the text will be divided into the heading wise summary. From each heading, 33% of sentences will be selected as a main summary, providing very concise and a short summary. So sentence ranking, the Fuji rule is transferred using the, here we are using the triangular membership functions with the following inputs and outputs. So here we are applying the Fuji rule, so which is using 10 input features. So based on these 10 features, so it will categorize the sentences which we have selected based on the heading into categories. So these 10 features are title, feature, sentence length, numerical data, bigrams, trigrams, term frequency, then position score, proper noun score, then thematic score, and cosine similarity. Then the we are getting the single output, which will give the quality of the sentences. So in each feature representation using the fuzzy membership function will add three set of linguistic variables such as low, moderate, and high. That means the sentences which is selected, that will be categorized into three types, that is low, moderate, and high, based on these 10 input features. So these are the 10 these are the input variables, and these are the rules we got. So based on these 20 features, we have categorized the sentences. So that is the first one is low, 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 low. If all the characters or criteria are low, then the sentence quality is not useful, so that should not be selected. So if it is high, then only you select the sentence into the summary. So after that, after selecting the sentence, that will be given to the by GRU. So this by GRU approach, this is efficient as compared to the long-term dependent system. It is very computationally inexpensive. So to overcome the traditional form of sequence to sequence model, a multiplicative based attention named long attention introduced by Thang Long. So the use of this attention helps to remember the dependency among the long term sentences which will be inputted as a text. Secondly, by using this by GRU, we are working on multiple documents. The additional requirement when we are comparing the single one is topic detection, ordering of the sentences, which reducing the redundancies. The proposed by GRU uses beam search decoder and bidirectional encoder. So finally, we are getting the summary, how to generate the summary. So this step is essential for obtaining the final summary, because at this step, the algorithm is used for the summary generation to decide exact figure of the sentences desired for the summary, which is based on the number of the sentences which are ranked of the limits for the final feature matrix. After selection of the sentences as for the score, it is necessary to assemble these sentences which we have assigned the ranks, and based on the heading we have selected the sentences whose rank is high. After getting that selecting the sentences, that sentences need to be ordered in the ascending order, so that we will be concatenating the assembled sentences to get the final summary. So in this proposed model, we have used the dataset as CNN Daily Mail dataset, BBC News for short multi-document, and archive for PubMed long document dataset. The various new categories are used like business, entertainment, politics, sports, and technical. So on the basis of the scores which we obtained for each these article, that will be analyzed for with the help of existing models. So here for the evaluation matrix, mainly we are using the RUS method. So here we use the RUS1, RUS2, and RUS-L. So that will be compared, the automated text summary which is generated by this fuzzy GRU based system will be compared with the human generated text summary with the help of this RUS matrix evaluation. So this is our experiment results. So first we have seen the quantitative analysis. So this is the first document text, and this is the second text, and this is the human generated summary. So by using this, when we are comparing this, so this is the final output which we have seen in this table 2. So this is the quantitative analysis. This is compared, or this is evaluated. This fuzzy YGRU is evaluated using the RUS1, RUS2, RUS-L for the news dataset articles. This is the output. So mainly we calculated these fall, recall, precision, fall, for RUS1, RUS2, and RUS-L for business, politics, entertainment, sports, and technical data from the BBC News dataset. So this is after that we have done the comparison between our proposed model with the existing three models. So here we compared this our proposed model with the TextLane, Yogo, and MSSF. So here you have seen our F major recall precision, that's value or score is more as compared to the existing three model. So this is the comparison of our proposed model for the RUS2 score, and this is for the RUS-L scores of our proposed model with the three existing. So for everywhere we have seen that our proposed model have given the good score for F major, recall, and precision. So this is the ROC curve analysis. And this is the graph where we have seen that when we have compared our proposed model having the highest score in case of your RUS N. Next is conclusion and future scope. So in this paper we have attempted a hybrid summarization model for long multi-documents, as it is mandatory for nowadays in the various domain. The proposed model first it will extract the features, and with the help of Fuji rules these extracted features are ranked, and then these sentences are inputted to the by GRU and undergone for the to create the abstractive summarization to select the most appropriate sentences, and the summary which is generated for the short multi-document and long multiple documents. The series of GRU when we are using we can attain the dependency among the long documents, and thus we'll get the attention result. The proposed model result superior when we are compared with the existing state of art models in terms of ROG1, RUS2, and L scores. In future, the model can be extended for the biomedical domain, as it is the most required field of the text summarization. So these are the references which I have done. Thank you.